Chapter 8, Section 1, Ratio and Proportion. After studying this section, you'll be able to recognize and work with ratios, recognize and work with proportions, apply the product and ratio theorems, and calculate geometric means. First, let's look at ratios. So a ratio is a quotient of two numbers. We can write ratios many different ways. Let's look at the ratio of 5 meters to 3 meters. We can write this as a fraction, 5 over 3, separated with a colon, 5 to 3, with the letter 2, 5 to 3, and with the division sign, 5 divided by 3. Our first number 5 is the numerator, and our second number 3 is the denominator. Now, unless we otherwise specify, we want ratios in lowest terms. So if we can simplify a ratio and pull out a GCF, then I want to do that. So the ratio of 15 to 6, I can simplify by pulling out a 3 from each term, and I can reduce it to its lowest terms of 5 over 2. Now, a very common type of ratio is slope. The slope of a line is the ratio of the rise between any 2 points on the line to the run between any 2 points. Another common type of ratios are scale maps. So scale maps give the ratio of the map distance to the actual distance. So here in this example, we can see that the scale is 1 centimeter to 30 miles. So on my map, 1 centimeter represents 30 miles in the real world. Now looking at proportions, proportions are related to ratios. The definition of a proportion is an equation stating that two or more ratios are equal. These three examples show us what a proportion is. So my first one, I have 1/2 is equal to 5/10. I know 1/2 is equal to 5/10 because if I were to multiply the 1 and the 2 both by 5, I'd get 5/10. Then my second, I have 5 to 15 is equal to 15 to 45. Again, if I were to multiply 5 and 15 by 3, that would get me 15 to 45. And then I have 4/6 is equal to 10/15 is equal to x to y is equal to 2/3. All these ratios will simplify to 2/3, which is why this is a proportion. Most proportions we'll encounter will contain only 2 ratios and not 4 ratios like this example. They'll be written in this form: a to b is equal to c to d, or this form, a to b is equal to c to d. In both of these forms, a is my first term, b is my second term, c is my third term, and d is my fourth term. Looking at the product and ratio theorems, in a proportion containing 4 terms, the first and fourth terms are called the extremes, and the second and third terms are called the means. Theorem 59 tells us in a proportion, the product of the means is equal to the product of the extremes, which we call the means extremes products theorem. You might have referred to this theorem in previous math courses as cross multiplying. This theorem allows us to multiply out a proportion, or probably what you've seen before with the little x of cross multiplication. So a times d is equal to b times c. Now, again, cross multiplication is just a trick. What's really happening is we're multiplying both sides by our denominators. So if I were to multiply both sides by bd, then b would get eliminated on my left side and d would get eliminated on my right side, leaving a times d is equal to b times c. Looking at Theorem 60, it states if the product of a pair of non-zero numbers, they need to be non-zero because we can't divide by 0, is equal to the product of another pair of non-zero numbers, then either pair of numbers may be made the extremes and the other pair the means of a proportion. This is the means extremes ratio theorem. What this theorem is telling us is if we're given a ratio, say for instance PQ is equal to RS, I can make PQ my means and RS my extremes, or I can make RS my means and PQ my extremes. So when I set up a proportion, I can create different proportions where P, Q, R, and S are all in different positions, but they'll give me the same equivalent equations. So I could have P over R is equal to S over Q, where PQ would be my extremes and S and R would be my means. I could have P over S is equal to R over Q, where S and R are still my means, but R and S switch positions. Or I could have R over P is equal to Q over S, where now my R and S are my extremes and my P and Q are my means. Looking at the geometric mean, in a mean proportion, the means are the same. So in my example, I have 1/4 is equal to 4/16. I know 1/4 is equal to 4/16 because I can simplify 4/16 to 1/4. So notice how the means are both 4. I can set these examples up with a over x is equal to x over r. So if I'm given two numbers where I want to find a mean proportion, then I can use a over x is equal to x over r. Now, if the means in a proportion are equal, either mean is called a geometric mean or mean proportional between the extremes. In other mathematics classes, you probably have had to calculate averages. The averages of two numbers is another kind of mean between the numbers called the arithmetic mean. We want to find the geometric and arithmetic means between 3 and 27. So if I want to find the geometric mean, I'm looking for the proportion that will make each ratio the same, where 3 and 27 are my extremes. So 3 over x is going to be equal to x over 27. Now I can use my means and extremes product theorem and multiply out. So 3 times 7 would be 81. That's going to be equal to x times x, which is x squared. Now this becomes a square root problem where I can just square root both sides, and then I'll get x is equal to plus or minus 9, because 3 over 9 is going to be equal to 9 over 27. These will both simplify to 1/3, making the ratios the same. Now, if I want to find the arithmetic means between 3 and 7, I'm just finding the average. So if I find the average, I add up all my values and then divide by the amount of values that I have. In this case, I have 2, so I divide by 2. 3 plus 27 is 30, divided by 2 is 15. So my geometric mean is plus or minus 9, where my arithmetic mean is 15. Now looking at our sample problems, we have problem 1. If 3 over x equals 7 over 14, solve for x. So here we have a proportion, so we can use our means extremes product theorem, which tells us we can multiply the means and then the extremes. So 3 times 14 would give me 42. 7 times x would give me 7x. I'll divide everything by 7. 42 divided by 7 is 6, so x is 6. Looking at problem 2, I want to find the fourth term, sometimes called the fourth proportional, of our proportion if the first three terms are 2, 3, and 4. So 2, 3, and 4 would be A, B, and C, and I'm looking for term D. So we know A over B is equal to C over D. So 2 over 3 would be equal to 4 over D. I can use my means extremes product theorem to multiply out. So 2 times D is going to be equal to 12. I'll divide everything by 2 and get D is equal to 6. Looking at problem 3, find the mean proportional between 4 and 16. So mean proportional was I'm looking for my means, and 4 and 16 are my extremes. So I can set up my proportion of 4 over x is equal to x over 16. I can use my means extremes product theorem to multiply out. 4 times 16 will give me 64. X times x will give me x squared. This case, I'll take the square root. So the square root of x squared will be x, and the square root of 64 will be plus or minus 8. So x is equal to plus or minus 8. Now we can have positive 8 or negative 8, but we have to be careful in certain scenarios and problems. If we're talking about, say, segment length, then I couldn't have the negative 8 value. If I'm just looking for the mean proportions, then I can have plus or minus 8. Problem 4, if 3x equals 4y, find the ratio of x to y. So I want the ratio of x to y, or x over y. If I want x over y in my proportion, that means I'd have to divide both sides by y in order to clear out this y. Doing that, I'd have 3x over y is equal to 4. Now I'd want to get rid of this 3, so essentially I'd multiply by 1/3. 1/3. This gets rid of the 3, leaving x over y, and then 4 times 1/3 would be 4/3. So the ratio of x to y is 4/3. Now looking at problem 5, is x over y equal to a over b equivalent to x minus 2y over y is equal to a minus 2b over b? In order to see if these are equivalent, I need to make them completely simplified. In order to make them completely simplified, I'll use my means extremes product theorem to multiply both of them out. If I do that for x over y is equal to a over b, this is going to be xb is equal to ay. If I do that for x minus 2y over y is equal to a minus 2b over b, if I cross multiply here, I'll have x minus 2y times b is equal to a minus 2b times y. Now distributing my b and y, I'd have bx minus 2by is equal to ay minus 2by. Now if I add the 2by to both sides, I can see that these will both go away, and I'm left with bx is equal to ay. Now I wrote xb equals ay. Bx equals ay is the same exact thing because I can rewrite bx as xb is equal to ay. In
So
today's
these
lesson, we
are
learned a ratio is a
equivalent.
quotient of two numbers, and a proportion compares two or more ratios. The means extremes product theorem states that the product of the means is equal to that of the extremes, and in a mean proportion, the means are the same. That's a wrap on today's video. We'll see you in the next one.